Welcome to The Explainer. Today, we're taking a trip through our cosmic backyard. But we're not looking at the big planets. Nope. We're talking about the small but seriously mighty objects zipping all over the place.
And you know what? This quote absolutely nails it. Don't let their size fool you. We're not just talking about some random space rocks here. These things are a direct link to the very birth of our solar system. They're like little time capsules, just packed with clues about how we even got here.
Okay, so picture this. Billions of years ago, way before Earth was even a thing, there was just this huge spinning cloud of gas and dust around our baby sun. Little bits started sticking together, growing bigger and bigger, and boom, you get planets. But a ton of smaller pieces got left behind. And the amazing part? They've pretty much stayed the same ever since. They're a perfectly preserved fossil record of that crazy, chaotic time.
So when we study these things, we are, and I mean this literally, looking back in time. Every single asteroid, every comet, is a little time capsule. It's giving us a peek at the exact recipe, the very ingredients that came together to create our world.
But here's where it gets really interesting. Their importance isn't just stuck in the past. Oh no. The story of these small bodies weaves right through our past, our present, and maybe, just maybe, our entire future out there in space.
So yeah, it really boils down to this triple threat significance. They could be the creators that kick-started life itself. They're a potential goldmine of resources for our future, and at the same time, they're a constant threat that we absolutely have to keep an eye on.
Let's zoom in on that first point, the whole creators thing. You know all the water in our oceans? Well, the leading theory is that comets and asteroids were like cosmic water delivery trucks for early Earth. But wait, it gets even crazier. Get this. NASA's Stardust mission literally flew through a comet's tail, grabbed some dust, and found glycine. That's an amino acid, one of the key building blocks for proteins. It's just incredible evidence that the ingredients for life might have been an interstellar delivery.
Okay, now let's look to the future. These small bodies offer up some mind-blowing opportunities. I mean, as we start thinking about venturing farther out from Earth, one huge question is, where do we get stuff? Well, asteroids could be the answer. They're like floating treasure chests, packed with the exact metals and minerals we'd need. And it's not just metals. The water ice on comets? You could break that down into hydrogen and oxygen. And what are those? The two main ingredients for rocket fuel. So these things might not just be places to visit. They could be the interplanetary gas stations that finally make long-term space travel a reality. How cool is that?
All right, before we go any further, we need to clear something up. The names. People get these mixed up all the time, but it's actually super simple. So let's play a little game. What do you call a space rock on its big journey to Earth?
It really is all about location, location, location. While it's just floating out there in space, it's a meteoroid. The second it hits our atmosphere and creates that fiery streak, what we call a shooting star, it becomes a meteor. And if a piece actually makes it all the way through and lands on the ground, you've got yourself a meteorite. See? Same rock, three different names.
And this isn't some rare, once-in-a-lifetime event. Scientists figure that almost 50 tons of this stuff, mostly just tiny dust particles, rains down on Earth every single day. That's right, the cosmos is constantly dropping by to say hello.
So, let's get to know the two main characters in this whole cosmic drama, asteroids and comets. Now, they're both ancient leftovers, but they are totally different. Think of it this way. Asteroids are the rocky, metallic guys that grew up in the warm inner solar system. Comets? They're the icy, dusty nomads from the freezing cold outer suburbs. So first up, asteroids. You can basically think of them as the construction debris left over from when the inner planets were built, and most of them just hang out in this massive belt between Mars and Jupiter. But they're not all alike, not at all. Scientists have sorted them into three main flavors based on what they're made of. You've got your C-types, which are the most common and some of the oldest things in the whole solar system. Then there are S-types, which are more stony, and M-types, which are loaded with metals like nickel and iron. And these differences give us huge clues about where they came from. Now, while millions of them are safely tucked away in that main belt, some are elsewhere. You've got the Trojans, which are really cool. They actually share an orbit with a planet, kind of locked in this perfect gravitational dance. But it's the near-Earth objects that really get our attention. And for one very, very good reason. Their orbital paths can cross ours.
Okay, so let's move on to their icy cousins, the comets. You've probably heard them called cosmic snowballs, or maybe dirty snowballs, which is a pretty great description. They're basically a frozen mix of gas, rock, and dust.
And just like asteroids, they're ancient relics. But their story started way, way out there, far from the sun in the super cold parts of the solar system. That's why all that ice was able to survive.
You know, for most of its life, a comet is just a small, dark, frozen core. Kinda boring. But as it gets closer to the sun, that's when it puts on a real show. The ice vaporizes, creating this huge glowing cloud around it called a coma that can get bigger than Jupiter. Then the solar wind blasts that material away, creating those spectacular tails that can stretch for millions and millions of kilometers across the sky.
And these amazing visits are often right on schedule. The most famous one of all, Halley's Comet, drops by every 75 years or so. So mark your calendars because it's due for its next big show in 2061.
And all of this brings us to a final and really crucial point. As beautiful as they are, as much as they can teach us, their impacts are just a fundamental part of how the solar system works. It's a cosmic process that, well, it both gives and it takes away.
I mean, impacts are what shaped the planets in the first place. They've changed the entire course of life on Earth. We all know about the one that hit 66 million years ago. The evidence is literally scarred into our world. You can see it in places like the huge Barringer crater in Arizona. And that right there is exactly why we have programs like NASA's Near-Earth Object Office today. Their job is to watch the skies, to be our planetary defense system, so we don't get caught by surprise.
So we're left with this incredible paradox, aren't we? The very same cosmic travelers that may have delivered the ingredients for life also pose a very real threat to it. They are both creators and destroyers. And figuring out how to handle that dual legacy, well, that's not just about learning about our past. It's about protecting our future.